Hello, everybody. As this is my first presentation for the day, I'm going to introduce myself. I'm Djurica, and I'm VP for Technical and Post-Processor Support. And it is clear, everybody here know that SolidCAM is the #1 CAM for the mill-turn and Swiss type solution, right? And of course, also our competitors knows about that we are the #1 CAM software in the world, right? Now, I'm going to tell you 10 facts and features why this is like that. So the first of all, it's clear. It's integration. I don't know any CAM software integrate as much as we do, right? We are easy to learn and fast to program. This is the most important fact in CAM industry, right? Our amazing toolkit. It's a breakthrough. You all know about this. It released in 2021. It is the best tool management system in the world, 100%. And it is also a platform that will allow us to make even more things in SolidCAM in the close future. We're going to see that very soon. Our amazing toolpad. We have all solutions from turning to milling, eye machining. Our MCO cycles, they are predefined in our post-processor, give our users clear parameters that needs to be defined for specific programming. We have amazing channel synchronization for multi-channel machines. Machine simulation to simulate and verify our toolpad. Post-processors verified, always. Amazing technical support. And the last is the setup sheet. So let's go through quickly about each one of these separately. We are the #1 and still the only Swiss type solution within the SolidWorks. So if your customer have the SolidWorks, if he has in his workshop some Swiss type machines, we are the only one who can do it. The newest is that we have integrated into Solid Edge, right? And also Tiangong CAD. So this is another breakthrough in our integration. Easy to use, fast programming, fast learning curve, intuitive proven. Nobody can argue about that. It's so nice software to see, so many beautiful colors, it's so fast, so legit, so powerful at the end. And the most important, it's easy to use. And our toolkit, as I said, released in 2021, it gave us tons of possibilities. I'm going just to count some of them because they are was so important during our development that we ensure that we can support any kind of customer needs for the mill-turn and Swiss type machines. And one of them is definitely the fast configuration of tool layout. It is extremely important when you have Swiss type machine to exchange the configuration fairly quickly. So this is allowed just by 2 clicks that you can just switch between 2 stations. This was amazing, right? Support custom shade katas. Any 3D model on the internet, you can download and just make it that it's a tool. Indexed revolvers. We always support indexed revolvers, by the way, but this time it's on a completely different level, more easy to manage. We also support any kind of face, axial, angular, and multi-cutter holders, making sure what is behind the scenes, how to output correctly code, planes and stuff, very important. And in 2023, I'm going to talk in the next presentation. I'm so honored to have 2 presentations in a row. We used our toolkit engine and use these library possibilities and engine to allow users to define the fixtures. So something about the toolpad. We have a wide range palette of turning, C, Y, B-axis milling operations, including unique patented eye machining technology. Available only from SolidCAM ensures that every part can be optimally machined. There's endless capabilities in milling and turning. And we give the complete control over the x-axis. This is extremely important, positive or negative, rather that it's a milling or turning. and avoiding potential collisions with the neighbor tools. Also, of course, the polar coordinate interpolation, phase or radial, we fully support it. We make sure that whatever the customer has it on the machine, we support it through that as well. If the case that customer doesn't have the phase or radial interpolation cycles, we are going to anyway interpolate it. Of course, the customer is going to receive longer G-code, but the end results will be great. Another, using special holders may sometimes lead to a potential and risky situation, and it's very important that you have a possibility to index your pod and approach your toolpath from a different CX direction. This will ensure that your part is correctly machined with collision-free. Supporting thread reeling as an irreplaceable method in the Swiss-type machines for precise machining of medical screws. And we have, for customers, in our post-processors, we always prepare the minimum list of MCO cycles. And for all the audience and also for the live streaming, what are the MCOs? Those are predefined cycles that it's not really connected to a toolpath, but it allows us to control some parameters on the machine, and like a process of the pickup, bar transfer, cutoff, and stuff. So we prepared the minimum list of parameters, what is necessary to program-specific sequence. So in this case, we have just a pickup cycle where we dynamically, through the machine preview, give a user possibility to dynamically see everything in the machine environment. Synchronize, optimize, and maximize productivity through our channel synchronization. Amazing product, without which none of the multi-channel Milton or ERA Swiss-type machines would not be even possible. We create a lot of improvements in that area in order to achieve that. We have channel synchronization and clash avoidance, which marks the operations that require some action, that guides the user through the pointed arrows, as you can see over here. And the system knows exactly what controller logic is and checks the possibilities of synchronization. And we take into account machine kinematics, axis sharing, and synchronization weight mark rules. This is extremely important, as it's not something that you're going really to crash machine. It is not crash, but clash. But we don't allow user to simulate or even to generate a G-code in the case that something is wrong in the channel synchronization. So you're not losing time generating a G-code, going to the machine, and then discovering that something is wrong with the weight marks. So we are preventing users to make any mistakes in ahead. We support 3 different superimposition modes. Axis can be superimposed other axis where a slave is following the master. Mostly this mode started, I think, in the Milton machine, but of course it is irreplaceable in the Swiss type, especially if you are doing the cutoff and you are doing something with the chamfering. Every machine runs it, through the superimposition. It must do it. Without the superimposition, you are not a king of Swiss type, definitely. We reduce the machining time and stabilize the part machining by using the sharing axis and drive unit features. You all know these options. And of course, machine simulation. It's so beautiful. All the details can be catched here. The toolpath verification can be checked. We are making sure, providing full collision detection between machine components, workpiece, fixtures, tools, and holders, of course. Part transfer, simulating the cutoff, of course. And about the post-processors. For most of you, you know that post-processors is considered with the 2 files. One is the VMID that is behind the screen, and another is the GPP. In the VMID, we define complete structure of the machine and all related controller parameters, while the GPP allows us to generate G-code output formats specifically for the controller. And everything this is actually done, created, edited, and debugged within the Visual Studio Code. And we have developed so many of them. I'm just going to give you some of the machine brands that we have recently did. Of course, they are also for the Swiss type, also including the stars, citizen, tortoise, Tsugamis, all of them in front of yourself. These are the ones that we cooperated at most. And in the next slide, I couldn't put all the posts that we have here. This is one of the most updated based on this machining brands. But at the bottom, all of you are going to get this presentation, so you can always click at the bottom, so it will give you to the Excel sheet where we have all the posts available there, whoever is interested into it. And something about technical support. This is the most important element of CAM industry. Every CAM stands on the two legs. Software from one side and technical support from another side. If you don't have a good technical support, you cannot be good in CAM. Absolutely not. So SolidCAM is making sure that we always, whenever we develop a post-processor, we always go to the customer side to ensure that the defined post-processor works exactly on the machine. Now, for something like this, I mentioned that you need to have a technical team. SolidCAM always makes sure that we always train our team as well. So for example, in 2023, we had 2 post-processor training, one held in Belgrade, another in Bangkok, one for the Europe and another for the Asia. In total, it was 130 attenders for the only advanced Milton and Swiss type. So please, it's a huge team. So we are making sure that all our technical guys is up to date for the version to get most of it of our software. And as you can see here, this is the Talentin, one of our first Swiss type projects that we have, again, to ensure that the defined post-processor works at the customer side. And this is the recent training in Belgrade. We had it in February. And the last point of my presentation is the setup sheet. In the past, you all know this was called tool sheet. We changed now the name to the setup sheet. It involves more. And this tool was ordinarily made by Stanislav Vavrik. I don't know, I see you, you're there. So, and everything was very good, but he always wanted to bring it to the higher level. So we involved also Milan Grigorjevic, who is also the manager now for it. And together with Ruti, I called this fantastic trio who bring, tool sheet to the setup sheet level, what is today. It is completely amazing. And it was so important when I was going to the customer side, especially for the Swiss type. They always were demanding different format for the setup sheet. So we wanted to make sure that we can do that, right? And something about that, I want to encourage every customer now who is watching us also that they can go to the setup sheet.solidcam.com. They can make their setup sheet by themselves. It's so easy, it's so intuitive. For the all milling applications, you can do it for the most and latest SolidCAM version, just online. Just download it, there's full instructions. And if you struggle somewhere, you can also Google, you can also go on YouTube and you'll find 3 videos about it, as simply as that. And last, for the 2023, we also start supporting channel synchronization. So the channel synchronization will be able also to be completely exported from channel synchronization into a PDF or any other format. And thank you for this. This was my first presentation, and hope you like it.
Daniel, wait, there are 2 questions.
Okay.
One is, can the setup sheet be exported for Swiss type? And the other question is there going to be a webinar for all the technical stuff that you talked about?
Okay, great question. Okay, first, yes, when we say the channel synchronization, even if it's Miltern or Swiss type, yes, absolutely, we can generate it either for the Miltern and Swiss type together. And the second, technical, yes. So after this EMO, after this exhibition and after the EMO, we are going to create some technical webinar series, also connected to my next presentation, so please stay tuned. I'm going to jump into another presentation. Okay. My next presentation It's about what's new in SolidCAM 2023 in general, and also about SP1. And you heard that I'm Vice President for Technical and Post-Processor Support. But lately, I'm honored to be also in R&D as well. And I got that opportunity to be also involved some of part of the modules in SolidCAM. So thank you SolidCAM for that. Now, what I'm going to tell you about. So first, it will be about the setup sheet, toolkit, and channel synchronization. Now, you probably have seen in my last presentation that we are now going to allow users to define fixtures through our toolkit. Now, let me tell you a short story about it. As I was doing a lot of mill turn Swiss type, going to the customer side, and I was thinking, how we can improve this. Let me just short you a little bit something about 2022. Fixtures in 2022, you could always do it in the way that associative fixture, where you have the 3D model in your CAD environment. In SolidCAM, you pick it up, that's your fixture. So this was like 3D model of fixture associativity. This was running great. We had two more options. One was the 3D parametric jaw, and it was 2D sketch jaw as well, right? So this was all supported in previous versions. But what always bothers me, like why every time I need to define chuck, my vices, and from part to part, like this was always for me a struggle. Every time you need to define it for every single CAM part. And we were thinking about, we have amazing toolkit. All these possibilities, libraries, how to manage the 3D models, machine preview, everything is there. We also say in 2021 that this is the platform for the all future development. This is another step that we are doing it. We allowed, from now on, in 2023, fixtures to be defined there. You've probably seen a lot of presentations about it in What's New. Emil shared it already by the email. Of course, you've seen it. And with the toolkit, when we add this option, there was completely irreplaceable that we also need to improve a little bit our machine setup. So we changed this also a little bit. So you got all of these slides and stuff, but I have decided that for this event, I'm going to do a live demonstration for you. I'm going to use a standard mill-turn part that I'm using in most of my webinars for this demonstration. It is a standard mill-turn part. I very like it. And I will just immediately jump into a setup. I'll open machine preview just to show you what is kinematic about. And we have here a classic NTX, 2 channels. There is no chucks, neither on main spindle, on the sub spindle, so there's nothing inside. Right. So what is changed here? Let me see if this works. It worked great. As you can see on the first side, it still looks more or less the same, but there are small things. So let me just introduce also for the people who know or don't know. Always this first page, we call it a fixture page, where you define your fixture, 3D model, and you are going to shift it relatively to your table station. Another page, which is this one over here, is a part mounting, where you're going to mount your part relatively to the fixture. Okay, so what has been changed? From now on, you still have the same options. I have no fixtures defined here at all, but I'm going to define them now. So you remember what I said. The first way, what we always supported is associative fixtures. So let me show you how you can do it now, and what is actually different. So you could still go with these 3 dots over here, but you can also click on this icon over here. So I'm going to open a toolkit, and on the first side, you can see that everything is more or less the same as the toolkit. But don't be fooled, because this is not 100% the same application as the toolkit itself. So the first thing, as you can see, on the far left, you don't see any You don't see any tools that you can define here, but strictly only the fixture. So the first thing that we have add is this fixture icon over here. Right after it, we have a space where we define all possible components that you could do for the fixtures. So the very first is associative fixture that I just talked about now. Then we have these two elements or components consist of every fixture can be made by using only these two components. They're kind of 2D, as you can see, as a drawing. So those are main components. And also at the bottom over here, you can see that we, for SolidCAM users, prepare three templates for the vise, chuck, and collet chuck that you can just drag and drop and it all works. To make it easier so they can see how we actually build those things. Okay, so over here, I only see my tables. I see nothing more. And what I'm going to do, over here in my project, I have prepared a collet. Now, for all milling users, you can imagine that you have a huge libraries of components for your vise or stuff. So I just use this particular component, very simple, just to demonstrate you how you can define. I just drag and drop associative fixture on my main spindle. I will click on Import from CAD. And you're getting to the same interface as you had it before. So you click just on the 3D model. I can call it here, call it. And here, as standard, you have still the fixture mounting coordinate system and part mounting coordinate system. I'm going to define them. They will be here at the bottom. This will be the mounting point. And over here, I would like to define my part mounting point. So let's click on that. And what is now different? This is pretty much the same interface that you can see for the coordinate system management, but you see that very first time, a great job by Sydney and their team, development team, they make associative coordinate system. Now, in any earlier version, we never support really associative coordinate system in fixtures. And I'm going to show you what is the benefit of using that. So I'm going to just click on this. The coordinate system is created. I want it over here. So I'm just going to pick the Z level, click on this surface. It's clear that my coordinate system is created. I click OK. I'm going to repeat the same process for my part mounting coordinate system. But this time, I'm going to click on this. It is there. I'm going just to ensure that it's always on this face over here. I'm going to click OK. You can click also on these icons to ensure that your coordinate system has been created. Of course, this is not a must. If you don't create it, then the coordinate system of Mac will be used instead. But I want to use it in this demonstration to show you the power of associativity. I'm going to click OK, and the behind the scenes, SolidCAM is actually generating the STL out of it. Here it is. So on the right side, you can see for the first time my mounting position, but also something that we never had before. We visually display for you where is my part mounting, so for the offset, you can offset it from that point. And over here, you can see the structure. I have the collet with my index here that is associative, and I have the part mounting. Now for the first time visible, and a new component in a toolkit. I'm going to click on it, and because it's associative, you can see that I read all the data correctly, and it is not possible to change. You can change it only inside of your CAD model. All right, so that's great. I'm going to accept that. I like this fixture, and it's there. My part is there, my fixture is there, done. Now, if I click on this part mounting over here, I can now offset my part. Let me just move it. But what you can see now, here, you can see this part mounting now for the first time. So every shift and rotation is based on this coordinate system that you can see. Okay, great. So what's next? Let me put this on 80 here. Everything is okay. I'm going to save and exit here. Now, I don't need this 3D model anymore. I'm going to hide it, and I'm going to show you one toolpath that I have over here. This is just a simple finishing turning toolpath that goes along and fairly to the middle of the part. You can see that clearly. I'm going to open my setup again. I will go to my part mounting. I'll open a preview. I will use my also focus on the target. I can also use these tools. And I will, for this demonstration, I will move it a little bit further, just for the purpose. It is clear that if I put my fixture and part in this setup position, my turning toolpath is going to hit my chuck, my collet button. I'm going to send to an exit. Nothing has to be recalculated. It is done on the demand. I will do a right click and calculate. New toolpath is there. Let me show you a couple of more things. So we always had these features, but not too many know about them. So I have here my SolidWorks environment, but you could always click on this small icon over here. You can click, and now you can, even in SolidWorks environment, see where you actually are at any moment. What you can also do, you can generate a fixture envelope. You have the icon over here, and you can click. And now SolidCAM is going to generate envelope of that. And now I don't need this anymore. I can continue working, and I know where my fixture is. So what is happening if I just take this and I just move it? I just click on this. I don't need to go to the preview. Fairly new position. OK, let me generate it again. The previous one will be removed. The new one will be generated. All right, so this was more or less all the things that you can do even in the milling application. There's no boundaries on that. But I want to show you something more. So I will just click this on none. I don't want to use any. And I'm going to open the toolkit. I'll open my machine preview. I have no chuck. I have nothing there. And let's see how easy today is to define a chuck. Many Milturn users, let's say not really many, but I would say like 25 or 30% of them, fairly oftenly for a specific Milturn application, they are changing their chuck to the bigger, smaller one, or maybe sometimes to the collet. You never know. For those kind of customers, you want to have a fast solution that he can pull out from the library and use it very fast. So how to use the chuck? Just take this template over here, drag and drop, your chuck is done. Now, if I look at this, so I have the chuck body, I have my part mounting, I have a jaw. So we have, let me just close this one. I can now visually again see the part mounting. And this was always like a challenge. Some customers like to measure the offset from the face of the chuck. Some customers would like from the face of the jaw. No problem. In any moment, I can go to the part mounting. I can put here the correct values. And here it is. I can now give the user all possibilities how this will be measured. Let me bring it back to original state. And let me just click on the jaw page. This is something that you are probably familiar and seen it before. But it is organized better, of course. But from another side, we also have all those I'll call boxes with values, but they are dynamic. What it means, so for every value that you change, everything is very dynamic. And another improvement, small improvement, is that every of those steps now can be defined. In comparing to the previous version, where this was not possible, we define it differently. We can also define the number of steps. Now, for the first time, we can go with 1. We can go with 2 steps. We can go with 3. Also, the number of jobs, I can define 2. I can define 3, 4, 5, and so on. Look how fast this is. Also, I have my clamping reference position, so I can, in any moment, change my reference point. So I can just say this. I can also increase my clamping. I can flip my jaws. It's so nice, so intuitive. What do you say? Okay, let me do something. I will flip this around, put this to 0, and my part dimension is, let me check, it's 40. So my stock is here seems also 40. So I'm going to define my clamping dimension like 50. So let's imagine that I place it a little bit opened. And this is, of course, you never know what clamping dimensions you're going to have. So you can just leave it more open. And I'm going to accept it. Okay? I'm going to open my preview. My part is over here. I'm going to move it to the part page. Let's say I want it here. Okay, what we have here, more. It's obvious that my chuck is moving everything. I can control the clamping positions and stuff. I have here clamping axis that I can control. This 50 M that I put, you can see it also here. But we have something new. We have also something we call auto clamp option. So I'm going to position it here, and I'm going to click on this auto close on stock. Next option, what I can do, it's auto close on target. Very convenient when you have a back spindle as well. So of course, in this case, my jaws are going to be closed on already machined geometry. So in this case, I will just auto close on target. Here it is. So please, do me sometime. So what is the advantage of all of these? So I can now predefine all of this, and I can store it in my library, reuse it in my project. So let me go next thing. I'm going to set this to none. And let me show you the library itself. So you can click on the library. And here I have predefined all standard chucks, vices, and collets that I could find. And those are kind of components. So what is different? It's different that here you have those fixture folder, and now you can, in the same way how you define your cutters, shanks, adapters, and holders, now you also have a fixture holder. Okay, I also have predefined my assemblies. So I have here a metric, and I can, for any, I predefine my vices, but here I have some chuck that I can say, let me put this one on the main spindle. Here it is. It's completely 3D model defined. I have just defined them. I just download the 3D model from the manufacturer. I predefined it inside my toolkit. I just drag and drop to my table station. Close on stock. Done. The same wise, I can just place it on the sub spindle. I can define all those things. So all things are more or less the same. But let me show you another things, another small technical stuff. Not only that you can do it like auto close, but you can close it to any clamping dimension. So for instance, I can just click on this dimension over here, and I can click on this diameter. You can see dynamically how he changed it. I can click on this, I can click on this diameter, and it's changed as well. Small details, right? And before I go to milling application, I want to also show you a couple of things there. Small features more inside the toolkit. So we have here at the bottom, favorite tools, a new option here available, which allows you to seek for the last 10 tools, cutters, shanks, and holders that you use it. Very convenient, especially if you're oftenly jumping from one library to another library. You can very easily, locate those components, and you can easily drop it in your project there. Also, there's an option that you can do a right-click, and you can pin it, as I did it over here, and there is a small index here that this particular component is pinned, so to ensure that every time when you go to the toolkit, you're going to see this particular tool. Also small feature there, and improvements. And now, something completely new that we never had before. And it's connected more or less to linear and revolvers that I like to. I was always struggling, and I know that every one of you was struggling with this. And I'm going to take one example here. I'm going to take this tool, the assembly tool assembly number 2. I'm going to select this tool component. I'm going to close this and just use it like so. Okay. I'm going by the purpose. Here, this is selected over here. And I'm going to select this component only. And let's say that I'm going to shift it in some unknown direction. Many times it happens to you as well. So let's say something like this. So I remember our very first versions of the mill turn. For me, the biggest challenge was I want to know how to snap to those surfaces and to place my tool into a holder, into a shank, right? So how to do that? There is a new tool, and you just click on specific component. If I click on this shank over here, it will move together also my insert. And you have an option here. It is called Calculate Orientation and Position. I'm going to make it a little bit bigger so you can see it. And when you click it, it will pop up something like this. It's a new tool completely that allows you complete manipulation of your STLs inside the toolkit. But not only toolkit. The same tool you will find inside the setup for your fixture movements and also part relative movements. So, how it works? I'm going to click on my surface, which is face number 1. Face number 2, I'm going to match. If you want to undo it, I can just undo it. I don't like it. I want just to move it along the z-axis. As you can see, this is along the z-axis. So I can just say here, I want to move along the z-axis, just z-axis. Then I can delete this. Let me click this and this one. So I have two surfaces. I want to move it along the x. Okay, let's go to along the x. There you go. But I want to apply the 10 of millimeters in the distance. So here's the 10, or maybe you want 20. Or maybe you want to flip it. Complete manipulation is now allowed. This is not only in toolkit, also inside machine setup. Another feature that is not finished, but we are working on it. You can see it. Just to bear in you that we are working on the feature to allow also selecting on the specific surfaces and circles. So stay tuned with that. It's coming in the next releases. I'm not going to save it, and let me go to a milling application. As you see, I'm using fairly simple parts, and in this case would be also the same. And what I want to show here, I didn't show in, of course, I didn't want to really attach my vise on my spindle. That will be pretty funny. And for this, I just have fairly simple part. I have one machine. I have also no fixtures defined. My part is inside the table. Everything is there. So let me see how to define a vise. I will open my tool viewer, and I have here the station. What is enough is just take the vise, place it on station. This is, guys, what you're going to get as default. Whenever you drop this particular vise, it will be there. This is a default one. But of course, you can prepare And this is, I think, ultimate goal, to prepare already a database. So I have here one that uses something like this, pretty much soft jobs. I have my clamping axis. So I can move my clamping axis, as you can see here. Of course, I will just leave this value, as you can see. I'm just going to accept it. It is there. Because my machine, it's like there are components that I'll just hide it for a moment. I'm going to move my part along the y-axis, just like so. And again, you have close. That's it. But that's not all. In any moment, guys, what is the power of it? Very often, you want to change some of the jobs, right? So here is where your library gets into a place. So you can go to the chuck. I have here using, sorry, not chuck, but vices. I'm using this particular one where I have some of my list of the fixed and movable jobs. So I'm going to replace the fixed one with, for instance, this one. So I want this one, or maybe this one. Yes. So I'm going to take it. Just replace here. I didn't hold the alt click, so like so. And also for the movable, I'm going just to take it also and hold the alt key. There we go. What you can do also, you can click on any of these jobs and flip also work. When you flip those jobs, it is obvious you're going to get more distance space. If you have a little bit larger stock, you can also clamp it like this. All right. Next thing, let me just accept this. I didn't have to. I'm going to click on None. And for the first time, I want to show you something that we have completely new. I prepared this also as a component on the component level. And I here have 5-axis 3-sided. It can be also a pyramid system. Fixtures, you all know about this, you heard about it. Mostly our customers were doing this thing still, but like load it inside your CAD environment. And then just for every part, you need to, again, click, 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 click. Today, you don't have to do that. You just define it once, you're assembling, that's it. So I don't want to do it in the tool viewer, but I think it's more interesting to show it in machine preview. I'm going to take my table, drag and drop, drag and drop. It's a Lego, guys. It's just like play with this. You still can rotate your model as you do it also in all toolkit options. This is also available. You have here, I'm going to place, this is my number 1. Next is my vise. I'm going to place my vise. I'm going to place my Joe. Here it is. I'm going to add a part mounting. My part mounting, it's in my previous component, so I'm just going to measure. It's really up to you where you're going to place it, and for me, I'm going to place it over here, which is 62 something, so on 62.5 I'm going to place. Here it is. This will be my part mounting. I'll click OK. My part is, oh, I forgot to open it. So I have here my clamping dimension, so I'm going to open it to open position. What I can do now, I can just copy this. Look how easy it is, guys. Fixture, paste, paste, done. But this time, something is different. I have my part mounting 1. I do also have my part mounting 2. I also have my part mounting 3. Now I have a possibility for the first time to define 3 mounting positions. I'm going to click OK. I have my part. It is there. I'm going to click over here. What is now different? I have now 3 positions where I can place this part. So I can place it here, I can place it there, I can place it there. So it's really up to me what I want to do. I'm going to just move it here. I'll just ensure that, let me just place 10. I'm just going to close. You can see he closed properly. Or I can go a little bit further, just close it. Close it. I can also go, stay tuned. So I can go to the jaw. I can just flip it. I can accept it. It works also from another side. I click, close. So a lot of new possibilities, but everything at the end to the goal that we give users now an option to define all these libraries, predefine them, to not waste the time in preparing it. So you can prepare everything in ahead. So anytime when he opens a new project, all the fixtures can be defined for him automatically. 3 mounting points. What allows us? When you have 3 mounting points, you are allowed to create a new MCO, and you can take the CNC operator, and now you can move your stock from one vise to another vise. The same philosophy like in the mill turn, when we have a main spindle, sub spindle, at the end we add a new workpiece, and we are going to see 2 parts machined together. The goal is that you can also create it also over here. You can machine all 3 parts at the same time with one, inside one, of course, the channel synchronization is handling everything, but now this is possible. Let me go to my presentation. So the new fixtures will allow us to completely define modular concept of the fixtures, also replaceable tables, very convenient when you have a milling table or turning table in all previous versions. What we did, we create separate machines when he's doing milling capabilities, when he's doing turning, right? Complete control of the tombstones, of course. Now, with all this, and Michael is going to talk tomorrow in the roadmap for a SolidCAM, something that we are preparing in very close future, all these three part mounting points that you've seen, we want to do something further. And we are building a platform for it, so I will leave Michael also a few words for tomorrow, so stay tuned. And one of the reasons that pulls that is that our channel synchronization, we changed the name. We changed the name to the Operation Sequence Manager because even for some milling machines, these you are not really synchronizing any channels because milling machines are completely single channel, right? So we make sure that also for the future development, we change this to more logical name, which we call Operation Sequence Manager. Another feature that is very connected to axis patterns, which are mostly available on the Swiss type, is that axis pattern for the first and last was always the same. But however, now, especially this was for the star machines, that it's important that also the last can be changed to any you want. With my previous slide, a new license update for all users. Operation Sequence Manager for a single channel machine is now available for free. So what you need to do in VMID, you need to define that your specific machine is single channel and channel synchronization is going to be available. And with this, I'm going to thank you for your attention. I hope you like it. And
thank you. Daniel, there was one question. I don't know, maybe it was in the middle of your presentation. Somebody asked, is this possible for CNC rotary tables? I don't know what.
CNC rotary tables.
Something you were talking about, and they said, is it possible for CNC rotary tables?
Okay, good. Yeah.
Okay, after he answers, we go to a break for exactly 15 minutes. Please come back in 15 minutes.
So the question I hope it was about that. Imagine that you have a 3-axis Haas machine. I think it's good representative. And very oftenly we come with questions like, hey, sometimes I would like to put my 4th axis maybe along the x-axis, sometimes maybe along the y-axis. Sometimes I move it on my table, so I would like to define that, and not every time to change my post-processor. So this is just a small platform what we built in our, and also I don't want to ruin Michael's presentation for tomorrow, but we are working on this solution, of course, yes. Currently in 2023, no, but stay tuned.